Greetings. A team of SCUDEM-V 2020 consists of students Saumya Jain, Gauri Kotiwale, and Nanda N R, and our coach Dr Ambuj Pandey.
The split of the country of Sudan in 2011 led to the creation of refugee settlements in Uganda. Inevitably, there was a lot of dispute arose between the communities because the refugees who came to the settlement brought their culture as well. Many methods of dispute resolution were implemented, among which we focus mainly on three of them, namely arbitration, negotiation, and mediation. Forming some well based assumptions and creating a mathematical model of first order linear differential equations, we analyze how a community deals with a dispute. We have tried to answer the questions by the help of our model, like how do different parties agree to a method to resolve a dispute? How do the preferences of a settlement's population change over time? What happens when new people move into a settlement? How do their preferences change the current trends within the settlement? And what are the long term practices that will be adopted by the people in the settlement? We will look at the assumptions for our model. First of all, we are assuming that there are only three methods of conflict resolution present in the settlement, namely negotiation, arbitration, and mediation. Each person in a settlement must prefer exactly one of these methods at a given time. Moreover, any person moving into a settlement must also prefer exactly one of these strategies. Because of this, before we move further, we would like to divide the total population of a single settlement into three groups based on their preferred method of dispute resolution. Henceforth, we will talk in terms of these three groups and their interaction. Secondly, we are assuming that the rate at which new refugees are coming to the population is constant, and the death rate of the total population are also taken to be constant. Along with this, we are assuming that initially each group has non-zero number of people. Exchange factors between any two populations are taken to be constant over time. The choice of the method of resolution is based on absolute majority at the time of the start of the conflict. And once the method of solution is selected for a particular conflict, it will be used to solve that conflict irrespective of which method may dominate at any later point of time.
Now, let's try to form some intuition for a mathematical model. As mentioned earlier, we have taken our system to consist of three groups, their populations represented by Y1, Y2, and Y3, which are just the groups of mediators, arbitrators, and negotiators, not necessarily in the same order. These three groups interact with one another via the transfer coefficients alpha ij's, where alpha ij represents the rate of transfer of population from group J to group I. Alpha IJs are nothing but the number of adequate interaction per person per unit time, as can be seen by the derivation done here. The populations of these groups also change due to the influx of new refugees, represented by the AIs, and the removal of people due to deaths, represented by delta naught, which is the number of deaths per year per person. This is taken to be 0.0001. Now let's take a look at our mathematical model. As you can see, it is nothing but a representation of the flow chart using linear ODEs. We have clubbed together our transfer coefficients to get the exchange factors, the KIJs. These vary from -1 to 1 and represent two-sided transfer or the net exchange of population between two groups. I would like to remind you again that Y1, Y2, and Y3 are just groups of negotiators, mediators, and arbitrators, not necessarily in the same order.
We have used the following set of equations for plotting graphs where the death rate is constant as mentioned here. We have also taken time in years. There are two major cases. First, when there is no influx. Second, when there is influx. From these cases, we understand the long-term practices that will be adopted and how the preferences of the settlement changes over time according to how we have described the conflict resolution before. For the first case, when there is no influx, the first subcase is when one population remains. Part A. Here, when K13 and K12 is greater than 0 and K23 can vary over -1 to 1, then the Y1 population remains. So here K23 is equal to 0 and in the second graph K23 is equal to 1. Still we can see that the Y1 population is dominating over the period of 10 years. In the next graph, here we have changed K23 to -1. The only change we see from the second graph and first graph is here is that Y3 population is dominating in the beginning, and then Y1 takes over. For case B, where K23 and K13 is less than 0 and K12 can vary over -1 to 1, then the population Y3 will remain. It is essentially the same as part A. For case 3, K13 and K23 greater than equal to 0 and K12 less than 0, we can see that the population Y2 remains. In both the graphs, we can see on changing K12 by an order of magnitude, we only see the change in slope of the graphs for Y1 and Y3. In the next case, we are considering when two population remain. So part A is when K12 is less than 0 and K13 is greater than K12 and K23 equal to 0. Here we can see the two populations remaining are Y2 and Y3, with Y2 ultimately dominating. And in the second part, we have kept K13 as negative, that is less than 0, and K12 greater than K13, and K23 again 0. And here we can see that the Y2 population and Y3 population remain, with the Y3 population dominating. And the third case here is that K13 is equal to K23 and greater than 0, and K12 is equal to 0. Here we see that Y2 and Y1 population are equally dominant. Such equal dominance can be also seen when K12 and K13 is less than 0 and K23 is kept equal to 0. Then in that case, Y2 and Y3 population would be equally dominant. So we have also assumed that when two populations are equally dominant, the conflict arisen must not have been resolved, as there has not been any method that would have been popularly chosen.
Let's see what happens when our influx in each group is non-zero. The first two cases are examples where one of the groups will dominate. For example, as described earlier, this domination may be by arbitration in a state of emergency. Mathematically, this happens when all the exchange factors are non-zero. Which group will dominate can be guessed by taking a look at the exchange factors, that is, by seeing her population and exchanged among the groups. In the third case, two groups coexist in which one may dominate. For example, negotiation and mediation may too often be the most preferred and coexisting methods in a settlement. This happens when one of the exchange factors is zero. Note that so far we have considered the cases where initial population of all the groups is same. Let's try to drop that assumption and see what happens. As you can see, this graph is pretty interesting as it gives the possibility of dominance of every group for some period of time. This is quite a dynamic interaction with a very competitive environment. The preference of the total population shifts and reshifts till it finally settles on one dominating method.
Coming to conclusions, on comparing cases when there is no influx and when influx is present, we observe that the influx doesn't contribute to the nature of the graphs as much as the exchange factors. We also observe that the initial population in each group can change the nature of the graph. According to our assumption of conflict resolution, the time in which the conflict takes place plays an important role in the method of resolution, as the dominant population leads the way a conflict should be resolved. As with every model, our model too has limitations and has further scope for improvement. In our model, we have taken the death rate to be fixed over a period of 10 years, which may not be the case in reality, which can be affected by uh, things like pandemic or violent outbreaks. We have also considered the constant influx rate over the period of 10 years. I'm sorry. We have also considered a constant influx rate over a period of 10 years. We have not taken into account the limitation on the total population due to the limited resources of the settlement. We have considered the influence of each individual within a group to be equal. That is, Whether the individual is a significant leader or a normal member of the group, their influence is equal. Also, exchange factors are taken to be constant with time, which may not be the case. For example, great leaders may emerge from one of the groups, making its exchange factor large. We have only considered people to be sorted into three groups and not considered those who do not conform to the present methods of dispute resolving or are neutral, which may not be the case in real life. We have considered that when two populations are equally dominant, then we have considered that when two populations are equally dominant, then the conflict arisen hasn't been solved for that period of time, which may not be the case in reality.
We would like to thank our coach Dr. Ambuj Pandey who provided us with app material to prepare for this challenge. We would also like to mention Dr. Preeti and thank her who took time out for us to explain her work to us, which was a very great influence on this project. Thank you.